Analytical, synthetic, and other evidences in derivation of the structure of benzene. Benzene. Benzene is one of the most important organic compound with the chemical formula C6H6. It is a colorless, highly flammable liquid. It has a melting point of 5.5 degrees centigrade and boiling point 88 degrees centigrade. It is a toxic substance and is known to cause cancer with prolonged exposure. It is a planar molecule or flat molecule. All the carbon-carbon bond angles in benzene are identical, 120 degree. All the carbon-carbon bond length in benzenes are identical, 1.4 angstrom. Compounds containing a benzene ring are called aromatic compound. Benzene is the simplest aromatic hydrocarbon. It does not readily undergo addition reactions. It will undergo substitution reactions. Structure of benzene. In 1865, German chemist August Kekulé suggested that the benzene molecule is made up of a hexagon of 6 carbon atoms joined alternatively by double and single bond, and with a hydrocarbon atom attached to each carbon atoms. Calculate structure for benzene. If benzene was a straight-chain unsaturated hydrocarbon, it should readily undergo addition reactions just like other alkene and alkynes. For example, bromine, Br2 should add across the double or triple bond as shown below. Possible straight-chain structure addition reactions given below. But when bromine is added to benzene at 25 degrees centigrade at 1 atmospheric pressure, no reaction seems to occur. So the possible structure for benzene involving double and or triple bond arranged in a chain seemed most unlikely, as these should undergo addition reactions. If bromine is added to benzene in the presence of FeBr3, it undergoes the substitution reactions in which one of the hydrogen atom is replaced by a bromine atom to produce a compound with the formula C6H5Br as shown below. Benzene reacts with bromine in the presence of FeBr3 to give bromobenzene. Catalytic hydrogenation of benzene yield cyclohexane, and it indicates the presence of closed ring of 6 carbon atom in benzene molecule. Next, benzene gives substitution reaction to form one or more only one monosubstituted product. Like benzene then reacts with bromine in the presence of Lewis catalyst like aluminum chloride and ferric bromide at room temperature gives bromobenzene, which is a monosubstituted product. Benzene forms three tri-substituted products which were again explained on the basis of ring structure of the molecule. When a substituted bromobenzene reacts with bromine in the presence of ferric bromide, it gives three products: ortho-dibromobenzene, metadibrombenzenes, and para-dibromobenzene. This is resonating structure of benzene. Next, properties of benzene. The various properties of benzene are mentioned below. Benzene is invisible in water but soluble in organic solvents. It is colorless liquid and has an aromatic odor. It has a density of 0.87 gram per centimeter cube. It is lighter than water. Benzene has a moderate boiling point and a high melting point. Boiling point of benzene is 80.5 degrees centigrade and melting point is 5.5 degrees centigrade. Benzene shows resonance. It is highly flammable and burns with a sooty flame. Limitations of Kekulé structure. The structure proposed by Kekulé was unable to explain the following fact. First, the Kekulé structure predicts that there should be two different 1,2-dibromobenzene, but in the practice only one 1,2-dibromobenzene has ever been found. According to Kekulé, benzene contains three double bonds. The chemical properties of benzene should resemble those of alkene, but actually it is not so. Benzene is highly stable and forms substitution compound easily. The resistance of double bond in benzene for addition, ease of substitution reaction. Kekulé structure also predict two type of bond length, that is for single bond 1.54 angstrom and for double bond 1.34 angstrom. Actually all bond of benzene are of equal length. Uses of benzene. Benzene is used in the preparation of phenol. It is also used to prepare aniline, used in dyes. In earlier time, benzene was used in degreasing of metals. It is also used for manufacturing of nylon fibers. The main use of benzene is that it is used in the manufacture of other chemicals such as ethyl benzene, cyclohexane, cumene, nitrobenzene, alkyl benzene, etc. It is also used in various industrial processes such as in manufacturing of lubricant, plastics, rubber, dyes, synthetic fibers. It has non-industrial uses too, which are limited due to reason benzene is toxic and carcinogenic.